Hey everyone, and welcome. So in pretty much every office, every school, you name it, anywhere you see a bunch of computers, there's this little box with blinking lights just working away in the background. That, my friends, is the network switch, the unsung hero of our digital world. And today we're going to pull back the curtain and see exactly what makes this thing tick.
I mean, have you ever really thought about that? You hit print on some massive report, and somehow it goes straight to the printer. It doesn't show up on your coworker's screen or, even worse, your boss's computer. How in the world does your request find its way through that tangled mess of cables to that one specific machine? What's stopping it from being total chaos?
Well, the answer is this gadget right here, the network switch. The best way to think about it is like a super smart, super efficient traffic cop for your local network. It's standing at a busy digital intersection, but instead of just waving all the traffic through, it looks at every single piece of data and gives it personal directions to its exact address. No mix-ups, no accidents.
All right, so to really appreciate just how brilliant the switch is, you kind of have to understand the chaos that came before it. We're going to take a look at how switches evolved from older, dumber devices and brought some serious order to our networks, getting rid of all those digital traffic jams that used to be a huge problem.
See, before switches, we had these things called hubs. And a hub was, well, it was simple. Imagine your entire office network was just one big room. When one computer wanted to talk, it just shouted, and everybody in the room heard it. Now, what happens if two computers shout at the same time? Yep, their messages would just smash into each other. That's a data collision. It was messy, it was loud, and it was super inefficient. So how does a switch do any better? Well, it's not a shouting room. It's more like a building with private hallways. And the secret to its intelligence is its ability to learn. A switch actually builds its own map of the network, like an address book, so it knows exactly where everybody is. Picture this. You take a brand new switch right out of the box and you plug it in. At that moment, it knows absolutely nothing. Zero. Its internal address book, which has the fancy name of a MAC address table, is completely blank. It has no idea what computer or what printer is plugged into any of its ports. It's a total clean slate. But the learning starts the instant a device sends out its first piece of data. So let's say your computer plugged into port 2 sends out an email. The switch does something really clever. It peeks at that data, reads the sender's unique ID, that's the source MAC address, and it makes a little note. Okay, device AA is on port 2. And boom, it adds that right into its address book. And this address book? This is everything. The MAC address table is basically the switch's brain. It's just a simple but super powerful list that connects the unique hardware address of every device to the physical port it's plugged into. This little table is what lets the switch go from shouting at everyone to making quiet, direct deliveries.
So, this all comes together in a really elegant process. For every single chunk of data, or frame as it's called, that comes through, the switch follows a simple two-step rule. First, I learn, then I forward.
So it's this little two-step dance, right? Step 1. Learn. The switch looks at where the data came from and updates its address book. Got it. That PC is over there on port 5. Step 2. Forward. It then looks at where the data needs to go, the destination. It checks its address book and asks, okay, where is this guy? If it finds the address, it sends the data out only on that specific port. No more shouting, just a private conversation.
But what happens if the destination isn't in its address book yet? Good question. In that case, the switch kind of has to go back to the old way of doing things just for a moment. It does something called flooding. It sends the message out of every single port, basically shouting, hey, is anyone here with this address? But, and this is the really smart part, when the right device answers back, the switch is listening. It learns where that device is from its reply, and it adds it to the address book. So it only has to ask once.
Okay, now this is where things get even more interesting. It turns out, not all switches make these decisions in the exact same way. There's this fundamental trade-off that network engineers have to think about. Do you want to be fast, or do you want to be careful? And this leads to two totally different ways of switching data.
On one side, you've got the store and forward method. This is the careful, meticulous one. The switch waits until it has received the entire chunk of data. It runs a quick error check to make sure it's not corrupted, and only then does it send it on its way. On the other side, you've got cut-through. This is the need-for-speed approach. The switch just reads the destination address at the very beginning of the data packet and immediately starts sending it out the right port, without even waiting for the rest of it to arrive.
And this shows the difference perfectly. On the left, with store and forward, you can see the switch is taking in the whole package, all the way to the end to check for errors. Only then does it send it out. But on the right, with cut-through, the second it reads that destination address, boom, that data's already heading out the door. It's a classic engineering choice, right? Accuracy versus latency.
So, what's the big deal with all this smart forwarding? Well, it has a massive impact on managing network traffic and digital crowds. By creating all these private little conversations, switches totally change the way our data travels, and they help us control two really important ideas: collision domains and broadcast domains.
So first up, the collision domain. Remember our old friend the hub, the big shouting room? That whole network was one giant collision domain. The easiest way to think about it is a one-lane road. If two cars try to drive down it in opposite directions at the same time, well, you get a collision.
And this right here is the switch's superpower. Because it creates a private, dedicated connection for every conversation, it basically turns every single port into its own tiny little collision domain. It takes that one-lane road and turns it into a massive superhighway where every car gets its own personal collision-free lane. It's a game changer.
But there's a different kind of area the switch manages, a broadcast domain. You can think of this like a public announcement system for the whole network. This is a message that's supposed to go to everyone. Like a computer might shout out, "Hey everyone, can someone tell me the address for the main server?"
Now, here's a really important distinction. A switch will happily forward these broadcast announcements to every single device connected to it. It puts everyone in the same town square, so to speak. If you want to create separate town squares, like, say, keeping the accounting department's announcements separate from engineering's, you actually need a different device for that. You need a router. A switch manages traffic inside the town. A router manages traffic between towns.
So let's wrap it all up. Switches are just absolute powerhouses when it comes to fighting network congestion. They do it with ridiculously high-speed ports. We're talking up to 100 gigabits per second. They've got special hardware inside for making split-second decisions. They have huge memory buffers to handle big bursts of traffic without dropping anything, and they give you tons of ports to keep all that local traffic moving smoothly. So yeah, the switch is the absolute master of the local network. It makes sure your print jobs find the printer and your files find the server, all without a hitch. But what happens when your data needs to leave the building? How does it find its way across town, across the country, or even across an ocean to reach a server on the other side of the planet? Well, that is a story for a different kind of hero. That's a story for a router.